For this problem, I'll start by treating it as a homogeneous differential equation. We'll get y double prime plus 3 times y is equal to 0. So the auxiliary equation will be m squared plus 3 is equal to 0. We'll get m squared is equal to negative 3. We can now take the square root of both sides. We'll find that m is equal to plus or minus the square root of negative 3. So m will be equal to 0 plus or minus I times the square root of 3. So our complementary solution, yc, is going to be e to the 0x, this 0 comes from the real part of the root, times c1 cosine of root 3, this comes from the imaginary part of the root, x, and we'll have plus c2 times sine of root 3 times x. This e to the 0x term will just be 1, so yc will be equal to c1 times cosine root 3x plus c2 times sine of root 3x. That's it for our complementary solution. We can now find the particular solution. G of x is equal to negative 48 x squared e to the 3x. This is going to have some constant times x squared times e to the 3x. But if you remember, whenever we have an x squared term, we have to account for the possibility of the other terms of the polynomial. So we actually have to account for ax squared, but also b of x and c. So yp is going to be equal to e to the 3x times x squared, which was ax squared, plus bx plus c. I'll distribute this e to the 3x term to make it easier for the next steps. We'll get ax squared times e to the 3x plus bx e to the 3x plus c e to the 3x. We can now find the derivative of yp. Yp prime is going to be equal to this first term. We have to use the product rule. I'll start by taking the derivative of e to the 3x, and I'll leave x squared alone. We'll get 3a x squared e to the 3x, and the second term of the product rule, I'll differentiate the x, and I'll leave the e alone. We'll get 2a times x times e to the 3x. For the next term, we will also have to use the product rule. Again, I'll leave the x term alone, and I'll differentiate the e to the 3x term. We get 3 times b times x e to the 3x, and the second term will be b e to the 3x. And for the last term, we can just differentiate it directly. We'll have plus 3 times c e to the 3x. We have to take the derivative again, so yp double prime is going to be equal to, again for this first part, I'll use the product rule, same as I did before. We'll get 9a x squared e to the 3x. The second term, we'll get 6ax e to the 3x. For this next term, I'll use the product rule again, same as I did before. We'll get 6ax e to the 3x plus 2a e to the 3x. For this next term, I have to use product rule again. We'll get plus 9bx e to the 3x plus 3b e to the 3x. For this next term, we can just differentiate it directly. We'll get 3b e to the 3x. And for this last term, we can also differentiate it directly. We'll get 9ce to the 3x. We can combine some of these terms. These 6ax e to the 3x will become 12axe to the 3x. I'll add the first term down here. I'll bring down the next terms. I'll have plus 2a e to the 3x plus 9bxe to the 3x. These 3b e to the x terms can be combined. We'll have plus 6b e to the 3x. And lastly, we'll have the 9ce to the 3x at the end there. So now we have yp double prime. I'll write the yp expression again, because we're going to use it in the next step. It was ax squared e to the 3x plus bx e to the 3x and plus ce to the 3x. The original differential equation was y double prime plus 3 times y is equal to negative 48 x squared e to the 3x. Because yp is a solution to this differential equation, we can plug in y double prime and yp into this equation. Yp double prime was this long expression here. I can go ahead and copy that. It'll be the yp double prime plus 3 times yp. which again was ax squared e to the 3x plus bx e to the 3x plus ce to the 3x is equal to negative 48 x squared e to the 3x. I can distribute this 3 into all those terms. We'll have 3ax squared e to the 3x plus 3b xe to the 3x plus 3c e to the 3x. We'll be able to combine some of these terms. We have a 9ax squared e to the 3x and a 3ax squared e to the 3x. So this will become 12ax squared e to the 3x. We also have this 9bx e to the 3x and this 3b x e to the 3x, which will become 12b x e to the 3x. And we also have 3c e to the 3x and a 9c e to the 3x. So that will become 12ce to the 3x. And I'll just write down the extra terms we have. We'll have this 12ax e to the 3x, this 2ae to the 3x, and this 6be to the 3x. That will all be equal to negative 48 times x squared e to the 3x. We can now compare coefficients. On the right, we have negative 48 times x squared e to the 3x. So I want to look for any x squared e to the 3x terms on the left. There's 12a, and I don't see any other ones, so 12a will be equal to negative 48. I can divide 12 to both sides, and we'll find that a is equal to negative 4. Now I can compare coefficients for xe to the 3x. We have a 12b and a 12a. And on the right, there is no xe to the 3x term, so that'll just be 0. So we'll find that 12b is equal to negative 12a. So 12b will be equal to negative 12 times negative 4, which is 48. So 12b is equal to 48. We can divide 12 to both sides, and we'll find that b is equal to positive 4. Now we can compare the e to the 3x coefficients. We have a 12c, a 2a, and a 6b. And on the right, we have no constants, so that'll be a 0. We'll find that 12c is equal to negative 6b minus 2a. We can plug in the a and the b we found earlier. We'll get 12c is equal to negative 6 times 4 minus 2 times negative 4. 12c will be equal to negative 24 plus 8, which is negative 16. So 12c is equal to negative 16. I can divide 12 to both sides. So c will be equal to negative 4/3. Now that I have all of my coefficients, yp is going to be equal to e to the 3x times ax squared plus bx plus c. So yp is going to be equal to e to the 3x. A was negative 4, so it'll be negative 4x squared. B was positive 4, so it'll be plus x. And c was negative 4/3, so it'll be minus 4/3. We can take this yp, and we can use it to find the general solution. The general solution is given as yc plus yp. So the general solution y is equal to c1 times cosine of root 3x plus c2 times sine of root 3x plus e to the 3x times negative 4x squared plus 4x minus 4/3. And that is our final answer. If this video helped you, consider subscribing.